Dr. Aneela. I'm working as Assistant Professor in Department of Physics, B.B. Raju Institute of Technology, Narsapur. My course name is Applied Physics. Today I'm going to explain on the topic of helium neon laser. Outline of my presentation goes like this. So in the last lectures, I have discussed the types of lasers. The lasers are classified into different types based on different considerations. So majorly the lasers are classified into three types: the gas lasers, solid state lasers, and semiconductor laser. So in the last lecture, I have discussed the solid state laser. The example for the solid state laser is ruby laser, and so I have discussed in last lecture. So today I am going to discuss about the helium neon laser. So this is a gas laser. So the example for the gas laser is helium neon laser. Today I explain its construction, working, applications, and drawbacks of helium neon laser. And then finally I summarize today's class. So before going to discuss about the helium neon laser, first I'll explain the characteristics of helium neon laser. So here the type of laser is gas laser. So why? Because here we are using the two inert gases, helium and neon gases are using. So in the mixture of two gases in the ratio of 10:1. And the active medium is the mixture of helium neon in the ratio of 10:1. So here the active medium is available in the form of atomic. And here active center is neon atoms. So neon atoms are responsible for the lasing action. And the pumping method is electric discharge pumping is used as a pumping source. And optical resonator. So this optical resonator is the combination of two mirrors, pair of concave mirrors. Here one mirror is fully reflecting mirror and other one is partially reflecting mirror. So the combination of these two mirrors is called optical resonator or optical cavity. And the output power is which is in continuous waveform. The output coming from this helium neon laser is a continuous mode. And the wavelength comes from this laser is in the wavelength range is 6328 angstroms or 632.8 nanometers. So which falls under the visible region in our electromagnetic spectrum. So these are the general features of helium neon laser. Coming to the introduction of helium neon laser, this helium neon laser is the most popular laser, and the operating lifetime of helium neon laser has very long time, and it can be operated up to 50,000 hours. The helium neon laser was developed in 1962 at Bell Telephone Laboratories. And this helium neon laser is a gas laser, and it is a continuous 4-level laser. So here in this case, 4 energy levels will be going to participate for the lasing action. So this is a diagram shows that this is the energy level diagram for the 4-level laser system. So here 4 energy states are going to participate for the lasing action. So first I'll explain the working mechanism for the 4-level laser. So the same is also work for the helium neon laser. So here, this is the ground state E1. E1 is the ground state and lower energy state, and E2, E3 and E4. Okay. Here the 4 energy states are participating for the lasing action. E1 is the ground state energy and lower energy state, and the E2 and E3 are the metastable states. So E2 is the lower level metastable state, and the E3 is the upper metastable state, and the E4 is the high energy state or excited state. So initially the atoms are present in the ground state. So the atoms, due to electric discharge pumping, these atoms can go to the high energy state E4. So the atoms cannot stay more time here. So after completion of lifetime, so the atoms comes to the upper metastable state. So here for high energy state, the lifetime is 10 power minus 8 seconds. So for upper metastable state, this lifetime is 10 power minus 3 seconds. Okay. So after completion of this lifetime, the atoms comes to the upper metastable state. So here the atoms can stay more time than the high energy state. So the population inversion is achieved here, more number of atoms present in this state. So after completion of this state, again the atoms comes to the lower metastable state. So the population inversion is achieved between two metastable states. So again, after completion of this lifetime, so the atoms automatically comes to the ground state. So here the population inversion is achieved between two metastable states. So this process is continuously going on. So that's why the output coming from 4-level laser system is continuous mode. But as in case of ruby laser, the output coming source is in pulsing mode. So why? Because there, in case of ruby laser, the population inversion is achieved between the metastable state and the ground state. So there we could not maintain the population inversion longer time. So sometimes, so that's why the output is comes like this. So there is a signal and again gap, and there is a signal and again gap. So this is the output is pulse mode. But in case of 4-level laser, the output mode is continuously coming out. The laser beam is continuously coming out. So why? Because here the could maintain the population inversion very longer time, and also population inversion is achieved between two metastable states. That's why we are getting the output as a continuous mode. Okay, so that this is the major advantage for this helium neon laser. But in case of ruby laser, the output coming as a pulsed mode, that is disadvantage for the ruby laser. Okay, so next here active medium is helium and neon gases in the ratio of 10:1, and neon atoms are responsible for lasing action, and the energy source is two electrodes are fixed near the ends of the tube to pass electric discharge to the gas. So then coming to the construction of helium neon laser. Helium neon laser consists of a long, narrow cylindrical tube. It is made up with a quartz tube, and it is having dimensions of diameter around 2 to 8 nanometer and length around 10 to 100 centimeters. So this is the electric discharge tube, and this is made up with the quartz glass tube. And this tube is filled with helium and neon gas mixtures in the ratio of 10:1. And the pressure of the mixture of gases inside the tube is nearly 1 mm of Hg pressure is applied. So here the output power is mainly depends on the length of the discharge tube and the pressure of the gas mixture. So the two electrodes were fixed at both the ends, and so that the electric discharge is passed to the gas. And two optical mirrors were placed at both the ends. One is fully reflecting mirror and the other one is partially reflecting mirror. So the photons will move in between two mirrors, and some photons will escape from the partially reflecting mirror, so that will comes out as a laser beam. And so here in the active medium, the mixture of helium and neon gases are using in the ratio of 10:1. Here helium will helps to excite the process, and neon will provide the energy levels for the lasing action. So here helium will also help for the achieve the population inversion for neon atoms, and so here neon atoms are responsible for the lasing action. Even though neon atoms are responsible for the lasing action, so we are considering helium along with the neon atoms due to only two reasons. So the first reason is the helium atoms are lighter atoms than the neon atoms, so it can easily excite to the higher energy states. So that the more helium atoms can interact with the neon ground state neon atoms, so that lasing action can be done. So this is the first reason to consider helium along with the neon atoms. And the other reason is at high energy states, the helium energy levels and the neon energy levels have same energy, and both will have the energy very closer to each other, so that there is a possibility to transfer energy from helium to neon very easily. So that is the second reason. With these two reasons, so we are using the mixture of helium and neon gases. inside this active medium. Okay, and the next one is optical pumping. So here we are using electric discharge pumping used as a source. So due to this electric discharge pumping, the electrons will get accelerated, and these accelerated electrons will interact with this helium and neon atoms as well. So there is a possibility to interact these electrons with the more number of helium atoms. So that the more number of helium atoms are available in the high energy state, so the more number of helium atoms can interact with the ground state neon atoms. So in that way, the lasing action can be done. And the two mirrors were placed at both ends. So one is fully reflecting mirror and one is the partially reflecting mirror. So these two photons, the combination of two mirrors will capture all the photons which are present in the active medium, so that the laser beam comes out from the partially reflecting mirror. Okay, so this is about construction of helium neon laser. Next, coming to the working of helium neon laser. So here the lasing action is due to the neon atoms. So neon atoms are wholly responsible for the to done the lasing action, and helium is used for selective pumping of neon atoms to upper energy levels. Okay, so this I'll explain with the energy level diagram. So this is the energy level diagram for the helium neon laser. So here this is these energy levels for the helium, and these are for neon. Okay. So for helium case, in helium two high energy states are possible. Those are 2,1s and 2,3s. So here in case of neon also these are having two energy states, 3s and 2s. So initially the atoms are present in the ground state. Okay, the atoms are present in the ground state. So due to electric discharge pumping, these helium atoms goes to the high energy states. Those are 2,1s and 2,3s. Okay, so these high energy helium atoms interact with the ground state neon atoms, and then the neon atoms are also goes to the high energy states. Those are 3s and 2s. Okay, so whenever if the atoms are, these helium atoms are present in the 2,1s state, 2,1s energy level, so these atoms can interact with the ground state neon atoms. So these neon atoms will goes to the 3s level, 3s high energy level. Okay, so if the atoms, helium atoms are present in the 2,3s state, so these atoms can interact with the ground state neon atoms. So these neon atoms goes to the high energy state in 2s level. Neon atoms can present in the 2s level. So it means that the high energy levels of helium 2,1s and 2,3s have the same energy as in the neon case. The 3s and 2s will also have the energy same. So both the energy levels will have the same energy, and both will have the energy very closer to each other. So there is a possibility to transfer of energy from helium to neon very easily. The energy transfer occurs very easily. So this process is called as resonance transfer of energy. So here, so these 3s and 2s states are metastable state in case of neon. So the atoms can stay more time here in 3s and 2s states in case of neon case. So due to these two states, so in between there are sub levels in between 3s and 2s states. So from 3s to 2s there is a 3p level, and from 2s to 1s there is a 2p level. So among these four states, three prominent transitions will occur. Three laser transitions will occur. So they are, so if you see here, the transition occurs from three ways, from 3s to 3p level, and 3s to 2p, and 2s to 2p. So here, so these three prominent laser transitions will occur. So From 3s to 3p, the transition occurs. The transition from 3s to 3p level, giving rise to a radiation of 3.39 micrometers, and which lies in the infrared region. And there is a transition from 3s to 2p. So this is the longer transition compared to the 3s to 3p. So it emits the wavelength of 632.8 nanometers. And there is a one more transition, that is 2s to 2p. So this is the third transition. It emits the wavelength of 1.15 micrometers wavelength. So okay, among these three transitions, so this 3s to 2p is the longer transition when compared to other two. So these two means 2s to 2p and 3s to 3p are the minor wavelengths, and this is the major wavelength comes out as a laser source. So and which is falls under the visible region. So as we know, the laser has the main characteristics. The one of the main characteristics is, so the light comes from the laser it is monochromatic in nature and it has single wavelength. But here we are getting the three wavelengths, right? So how to overcome, how to remove the minor wavelengths, and and we need to consider only the major wavelength, right? So which is falls under the visible region. So that's why in construction itself we are using the quartz tube, and electric discharge tube is made up with the quartz tube. So the quartz tube, the role of quartz tube is it absorbs all the minor wavelengths and it emits only the major wavelengths. So that's why we are using quartz tube in construction, helium neon laser construction. So in that way we can remove the minor wavelengths, it emit only the major wavelength, that is 632.8 nanometers. So it is the output coming from this helium neon laser is 632.8 nanometers. And then after that there is a transition from 2p to 1s and 1s to ground state. So if you see here, so the atoms in the 3p and 2p level undergo a spontaneous emission to 1s level by fast decay, giving rise to photons by spontaneous emission. So here this transition from 2p to 1s, there is a fast radiative transition will occur. This is due to the spontaneous emission of radiation. And after that there is a transition from 1s to ground state. So this transition will occur due to the interaction of helium atoms with the walls. So whenever the helium atoms interact with the walls of the discharge tube, so that time the atoms comes to rest position. It means that the atoms are coming to the ground state. So this transition will occur due to collision of helium atoms interact with the wall of the discharge tube. Okay. So, and this process is continuously going on. So whenever the helium atoms are present in the high energy state, so the neon atoms are at ground state. So whenever these helium atoms interact with the neon atoms, these neon atoms goes to the higher energy state and this helium atoms comes to the ground state. So okay, so this process is continuously going on. So that's why the output coming from this helium neon laser source is continuous mode. This is the main advantage for this helium neon laser. So this is the working of helium neon laser. Next comes to the application point of view. So helium neon lasers are widely used in laboratories for all interferometric experiments, and these are mostly used in supermarket checkout counters to read barcodes. And these are helium neon laser scanners are used for the optical character recognition, and these are also used for the high security systems to recognize the things. And helium neon lasers are used by newspapers for reproducing transmitted photographs, and these are also widely used in metrology, in surveying, and as in alignment tool. And these are mostly used in defense applications. So these are used in guns to aim the target. And these are also used in holography to record the 3D images. So some helium neon laser has some disadvantages. Actually, the operating lifetime is long, but it's a low power device, and it means that the output power is low for helium neon laser. And this helium neon laser is a low gain system or it is a device. And from this, we'll get the we are getting two more wavelengths. So actually, the characteristics of laser is we need to get the single wavelength, but by using helium neon laser, we are getting three wavelengths. So in order to overcome those wavelengths, so it is a crucial job and to control the wavelengths. And for this, it requires a extra technical skill and cost, and it requires a high voltage requirement. So this is the main disadvantage for this. And here we are using inside the gas discharge tube, we are using the gas mixture of helium and neon gases. So some gases are escaping from laser plasma tube, so it is also a disadvantage. So if the gases are escaped from the tube, the lasing action cannot be done properly. So this is the also a disadvantage. So these are the few disadvantages for helium neon laser. And so with this, I'll summarize today's class. So I have discussed about the characteristics of helium neon laser, and then have discussed its construction and working of helium neon laser, and we have also seen some applications and disadvantages of helium neon laser. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.